Sorry, we're gonna move fast, because when I dry run this talk, it goes about an hour 20, but I still wanna get you guys out in an hour. So, like I said, welcome everybody. My name is Minnick. In this session today, we're talking about correcting common async await mistakes in .NET. Now, we are moving fast, but don't worry about taking notes, don't worry about memorizing anything today, because I've already done that for you. You just have to go to this QR code, or specifically to this link here. We'll take you to a web page where you can find all the materials from today. So this is where you can find a recording. Yeah, you can go take a nap, whatever you want. This is where you can find the open source samples. This is where you can find an actual 4-hour course I recently published where we go even deeper into this stuff. So hopefully you get excited about what we learned today and you want to learn more. You can find it all there. And if you have any friends or coworkers who couldn't make it today, you can also forward that on to them as well. And like I said, we probably won't have time for Q&A at the end, but you can find me online. This is my Blue Sky handle, codetraveler.io. I'll also be around all day today and all day tomorrow if you want to hang out and chat. But let's get rolling. So let's start by looking at this method called getLibraries. This is an async task method, and it's a fairly common use case for using HTTP client to call getAsync to return information from an API. But what's really going on here under the hood with multi-threading and async await in .NET? Well, to simplify the example a little bit, let's assume thread 1 kicks off this method. So thread 1 calls getLibraries. And so what happens is thread 1 enters this method and initializes this variable called response. But then as soon as thread 1 hits that await keyword, thread 1 returns. And now thread 2, or any background thread, is now running getAsync. And this is really, really good, because we don't want thread 1 to be making any API calls, because thread 1's a very, very special thread in .NET. It's also known as the main thread. It's also known as the UI thread. Thread 1 is the only thread that can interact with the user. And it's also the only thread that can draw the UI on the screen. So if we were not using async await for some reason, and thread 1 was calling getAsync, well, if getAsync takes 5–10 seconds, well, in those 5–10 seconds, if thread 1's busy doing that, if the user's scrolling the screen, tapping buttons, nothing's gonna happen, because only thread 1 could respond to those button taps. And so with async await, we don't have to worry about that, because now thread 1 is free. It's back interacting with the user. So while getAsync is running in the background, thread 1 or the user can swipe and tap buttons and do whatever they want, and our app's still nice and responsive. Now, what happens when getAsync is done, we return back to the calling thread for the next line of code. So thread 1 jumps back in here and makes sure that we have a successful response code, and then initializes this variable stream. And then, just like last time, it hits this await keyword. Thread 1 returns, and we run this on a background thread again. We'll call this thread 5. Again, this can be any thread from the thread pool. It doesn't have to be thread 5, and it won't be thread 5 every time, certainly, but when it's done, again, we return back to the calling thread. Thread 1 jumps back in, initializes this variable libraries, hits the await keyword again, deserialize async runs on a background thread. We come back again to thread 1 to return the value, or to throw an invalid operation exception just in case something went wrong. Now, to really understand what's going on here and how this works, we actually need to look at the compiler-generated code. So what I've done is I've gone to sharplab.io, which is an awesome, awesome website if you've never heard of it, because we can put in our code here on the left. So this is the same code that we're just looking at in nice, beautiful C#. And on the right, this is the compiler-generated code. And the first thing you'll notice, there's a lot more code on this side than I wrote on my side. And it's got like weird variable names, like in compiler-generated code, you'll see these weird angle brackets and underscores. And these are actually illegal variable names in C#. But the compiler does this on purpose when it generates our code, or generates code for us, so that we don't have any accidental naming collisions. But if you squint your eyes and look close enough, this really is our code. Like here's getAsync, and if we scroll down a little bit, we can see the JSON serializer in here. But the big thing we'll notice first is we now have this private struct that inherits from iAsync state machine. And just a fun fact, in release configuration, it's a struct. If we switch this to debug mode, this is actually a class, and you can see the code even gets even bigger. And this is just because when we debug our code, the debugger has to remember what the compiler or what the variable names are, whereas when we're running in release config, then the .NET runtime can optimize this a little bit more for us. But before we look at this async state machine, let's scroll down because we still do have a method called a public async task method called getLibraries. It's down here, but you'll notice this method looks completely different. In fact, none of the code I wrote is in my method getLibraries anymore. And that's because what's happening is .NET is building a state machine for us under the hood. And before we get too deep into this, I do want to say this is really cool stuff because C#, .NET, this was all invented before asynchronous multi-threading was a thing. You know, back when it first came out, CPUs were simple, just single core processors. They did one thing, but the really smart folks at Microsoft figure out a way that we could write nice, elegant, readable code here on the left, and then they handle all the mess for us underneath the hood by creating this giant state machine. So what happens now inside of the compiler-generated getLibraries method is we create our new state machine, and inside of it we have an async task builder created where we set the current state to be -1, and then we kick off our code here. We tell the builder to go ahead and start, and what we're actually returning now is the state machine's task. So this task is actually what we're awaiting here when we say await getLibraries. Now, if I scroll all the way back up, this is where that async state machine is created. And the big part of the async state machine is this move next method. This is what is going to iterate over our code. And you'll see in a second how this thread switching gets enabled under the hood here, because when move next starts, the first thing it does is it grabs a state, which remember this is always initialized to -1, and then we enter this giant switch where we have multiple cases. So we have our default case, but then we have case 0, case 1, case 2, and for us that's it, because we only use the await keyword 3 times. So we have case 0, 1, case 0, case 1, case 2, so 3 cases because we use the await keyword 3 times. If we use the await keyword a 4th time, we'd have case 4. But again, we start with case -1, which is our default here. And this is where we start by calling our code finally, where we say get async. And so now we've kicked off this task. It's running on a background thread. But the first thing that the .NET runtime does is actually look to see, is that task completed? Because we're going to be doing a lot of thread switching here, and thread switching is expensive. And we want to avoid switching threads if we can, because our code will run faster. So here in this release config, it's highly optimized for us. Fantastic. And so the first thing it does is see, is that already completed? Because if it is, then it'll use this goto statement, and it'll jump down to this IL_007E tag. So 007E is down here, where so if that task is already completed, it'll just get the result, and then it'll run the next line of code where it ensures that we had a successful status code. But we know this is calling getAsync. This has to go out to an API on the internet, so this will never be completed. So what really happens is we're going to enter this if statement, where now we're going to update the state to 0, because when we come back, we're going to jump back in to state 0 to pick up where we left off. But before we do, we have to save some values here, where we have a couple fields up above, like this U__1, where we're going to store the HTTP response task awaiter until it comes back. And then we're going to let .NET know that we are waiting on the result, or waiting on that task to be completed. And then finally, we return. So this is how the calling thread, in this case thread 1, is able to escape while everything's running on a background thread for getAsync. And then when it's completed, we now know we're on state 0. So we jump back into move next, and we do it all over again. But this time, we come straight into case 0, where we grab that value that we saved in the private field up above, and then we reset that field to, again, performance memory optimization here, help the garbage collector out a little bit. And they'll set the state back to -1, just in case something bad happens. If this task throws an exception or the app crashes, then we want to return back to, or we don't want to continue this task if something happens like that. And now we can finally go to IL_007E, where, just like we looked at earlier, we essentially pick up where our code left off. Now, I won't run through all of this, but eventually, we'll end up down here where we finally get our list of library models. We check to see if it's null. If it is, we'll throw an invalid operation exception, just like we said we would do in our code. and then we will save that result to result 3, where finally, down here, we call builder set result and pass in the list of library models. So this builder set result, remember, this is the actual task that we're really awaiting under the hood, and that's how we get our list of library models up here. Now, there's one really big gotcha that if you've never looked at the compiler-generated code for an async method before, you probably didn't know this existed, and that's this giant try-catch block right here. So all of our code, all of the get async, the read to stream async, deserialize async, all the code that we wrote gets put inside of this giant try-catch block inside of move next. And so what this means is, let's say we didn't get a successful status code back. It throws an HTTP response exception. So that exception will be caught here in this try-catch block. And normally, that's fine, because as long as when we call get libraries, we await it, as long as we say await get libraries, that exception gets rethrown. But this is where async await becomes dangerous, because if you don't await that task, that exception will never be propagated back to us, the developers, and it'll just be swallowed up here in this try-catch block and essentially gone forever. And this is what I didn't know when I first started writing C# code over a decade ago. I published my first apps to the App Store back in 2016. It was in Xamarin back then. Now I've ported them since to .NET MAUI. And I would occasionally, weird things would happen because I thought I knew what I was doing with async await, right? I was like, oh, I want this to run in the background. I don't care when it finishes. So I would say task.run. I'd put a bunch of code inside of task.run. And I was like, who cares when it finishes? It'll just finish, so I'm not going to await it. But what was really happening was sometimes my code was throwing an exception. But I didn't know that as the developer. And now you might be thinking to yourself, this is great. I hate exceptions. They crash my app. This is fantastic. I wish we could do this for all the code. But that's not the right way to think about exceptions. Exceptions are a good thing. It's the only way .NET can tell us that something exceptional, something unexpected happened that .NET doesn't know what to do. And as advanced C# developers, we should be catching those exceptions. We should be catching that HTTP response exception. We should be catching that invalid operation exception so that we can handle it. And because I wasn't awaiting those tasks in the first apps that I was writing in C#, I didn't know these exceptions even existed. So my app would get in these weird states where some buttons would be enabled, some would have the activity indicator still running, and that was because some code thought it was successful, but in reality, it had failed. So again, the good news is, as long as we await tasks, that exception gets rethrown to us, we can catch it, and then we can handle it appropriately. So quick review. The async keyword adds about 80 bytes. This is just because of all that compiler-generated code. Now, this is 80 bytes. This is really not a big deal. I'm not talking 80 megabytes. I'm not talking 80 gigabytes. It's just 80 bytes. So for most of us, even me doing mobile, which is less horsepower than making websites that run on a server, I don't care about 80 bytes. Use the async keyword as much as you want. But more of a fun fact that it turns our async methods into a struct specifically in that release configuration. And we want to await every task because non-awaited tasks hide exceptions. And that's the most painful thing you can do as a developer, is try and hunt down these bugs because somebody forgot to await a task. In fact, anytime I review a pull request and I see a task that's not awaited, immediately fail that pull request. The worst thing I've seen, and actually I was just joking that I saw it in Steve's keynote this morning, is where that pattern where people say _equals task.run. So not only are you not awaiting the task, but you're discarding it when it's done. So again, any exception that gets caught in there is gone forever. So don't ever do that. If you ever see those in pull requests, you should always fail that pull request because we need to await every task to get those exceptions. Okay, but enough talking about it. Let's actually jump into some code here. And I have with us today a .NET MAUI app that I've created that pulls down the top stories from Hacker News. So if you've never heard of Hacker News, it's essentially a forum where folks can post all the latest tech stories of the day. Other users can upvote and downvote them. So that's why you see there's points here. And so this app just goes and gets the top stories from the Hacker News API, and then I can click on any of the stories here and then read them in my app. So pretty simple one-page app. And what we're going to play around with today is inside of the .NET MAUI app, specifically inside the view model layer, I have a class called News View Model Bad Async Await Best Practices. This is what we're going to fix today together. But there's also good async await best practices. So again, don't worry about memorizing anything, because you can always just look at these two side by side when we're done. And so let's jump into it. So scrolling all the way up here, we have a bunch of to-dos we're going to fix together. Now, the first one here, we're inside of the constructor for our news view model. And I'm trying to call the refresh method. Like, this is the method that is called when the user does a pull to refresh. So this is what goes and gets the latest top stories and displays them on the page. And I'm calling it here in the constructor because I don't want the user to load a blank app and have to pull to refresh just to see the data they want to see by launching the app. Now, we're just saying we need to await every task. So, I mean, it seems pretty obvious, right? We would say async here, we would say await here, but no, we're in the constructor. We can't use async await in the constructor because constructors aren't meant for that. Constructors are literally just designed to initialize an object and maybe assign a couple of variables. And really what's going on under the hood is .NET's assigning a location in memory for this newly initialized object. So there's no async await in the constructor, so we can't await it here. But one thing I could do is I could create another refresh method down here where we'll call await refresh here, and then we'll just call this new refresh method here, and happy days. We don't get those yellow squiggles anymore, we're not getting yelled at, we're still awaiting that task, and everything's great, right? Well, yeah, I can see some people shaking their heads, I can feel the tension building, because what did I do? I just created an async void method. And what are we taught when we're taught to be C# developers? They say, don't ever use async void. It's bad. It's only meant for event handlers. And that's not bad advice, because actually, this is a valid use case for async void. But the problem I have with telling people just don't use it is nobody goes another step further and says, why? So why is this dangerous? Well, let's look at a couple scenarios here. What if I added some code here where I'm going to clear that top story collection, and I'm going to do some initialization here. We'll just add some dummy code here. And if we remember what we were just talking about, well, let's say thread 1 initializes the constructor. So thread 1 enters the constructor. Thread 1 hits the refresh method, enters the refresh method down here, hits the await keyword. So thread 1 returns. But because nothing's awaiting refresh, thread 1 continues running here while refresh runs in the background. Hopefully most of that's spelled right. So essentially what we've done is we've just created a fun little race condition where this refresh method's running in the background and it's editing the top story collection, but thread 1 is still running in the constructor at the same time, and it's modifying the top story collection. And if you've ever had to debug and solve a race condition, those are the worst, the hardest problems to solve because they're so hard to reproduce. They only happen occasionally. Some people think you're going crazy because you're like, I swear one time I saw it happen. And I was like, nah, that'll never happen. But that's a race condition where we have two threads doing conflicting things that interfere with each other. So this is one reason why async void's dangerous. Another reason async void's dangerous is what happens if refresh throws an exception, right? Like, this is going out to the internet, it's getting an HTTP response, and maybe the user's on a bus and the mobile app can't connect to the internet, or maybe we just do this to ensure that an exception, we now know we're guaranteed to throw an exception and refresh. So, okay, no problem, right? I'll just wrap in a try catch block, that's what these are there for, so we'll say try, we'll say catch, we'll handle that exception. But again, remember what's going on here is that thread 1 is going to come in here, hit refresh. Thread 1's going to enter the refresh method, hit the await keyword, return, and then thread 1 keeps going. And so now thread 1's down here. Meanwhile, this method is still running. So when this exception is thrown, we can't catch it. And this is really, really big problem because that's going to crash our app. And probably the worst part to bring this all together around async void is if we look at IntelliSense, what does IntelliSense tell us about this method? I need more patience, come on. There we go. it just tells us this is a private void method. And as advanced C# developers, it's completely valid for us to assume that this refresh method will finish running, will run to completion before the next line of code. So it's totally valid to assume refresh has completed here. But it doesn't tell us that it's async void. So, right here in this silly little sample, like the async void's in our face. We can see it right here. It's tough to miss. But maybe it's not. Maybe it's in a different class. Maybe it's in somebody else's library. So we don't even have the source code for it. And all we know is that this method returns void. And again, it's completely valid for us to assume that the method completes before the next line of code runs. But as we see now with async void, that's just not the case. So this is all bad. we don't want any of this. You want to avoid async void for all of these reasons, especially because eventually somebody new is going to join your team. And if you have a new junior developer who doesn't understand all this, and they're going to start copy-pasting your code, or they're going to be reusing your code, and they're going to run into all these same problems we just talked about. So let's avoid async void here. And what's something else we can do? Because I don't want to do any of this. I don't want to risk future bugs, more future work for me. That sounds terrible. Well, what I've done is I've actually created an extension method called safe fire and forget. Now, this is available in a NuGet package that I named Async Await Best Practices. And if we dive into the implementation here, under the hood, this is literally just an async void method. But this has all the guardrails in place to follow all the best practices where if we do use async void, this is what we got to do. So for example, one of the things, if you do use an async void method, you have to wrap everything inside of a try-catch block, because again, any method calling your async void method will almost never be able to catch an exception. So here, there we go. So here we're going to still await the task. If it throws an exception, we can actually catch it. And with safe fire and forget, we can even do whatever we want. So maybe we just say trace write line as a simple example here, handle that exception. And the best part is, by having it as an extension method, it's very explicit in your face. It says, hey, I know this task is going to run in the background. That's what I want. Like, it's very much signal to the other developers on your team is, I want this to run in the background, and that's okay, and hey, let's handle the exceptions if we need it. So I know I'm a little biased because I created the NuGet package, but it is available on NuGet, and it does have over 3 million downloads, so hopefully I'm doing something right. Last I checked, there's some crazy companies, like I think I saw Mozilla's using it now, which is wild. This is actually just a NuGet package I made for a talk back in 2018, and here we are, still talking about it. So, all right, so that to-do's done. Let's scroll down. What else do we have here? All right, so now we're in our async task method called refresh. Again, this is what gets called when the user does a pull to refresh. Now, the first thing I want to mention is this method is an async task method, and you'll see the parameter cancellation token. As good C# developers, anytime we have an asynchronous method, so anything that returns task, value task, async enumerable, we'll touch on those in just a minute, you always want to allow the user or the other developer consuming this to pass in a cancellation token, because we don't know how long this task is going to run. Or rather, if you wrote this code, I don't know how long your task is going to run. And specifically for like my mobile app, mobile apps or mobile devices are notorious for having bad internet connectivity. So if one of my users is on a bus and there's phones switching between towers, going through tunnels, and it's going to take 2 minutes to load all these stories, I don't want my users sitting there watching this task just spin for 2 minutes. Like, I'm just going to cancel the task and let the user know, hey, sorry, looks like you got a poor internet connection, try again later. Because otherwise, what's going to happen is the user blames me and gives me a 1-star review because I couldn't cancel your task. So as a good C# developer, we're always going to have cancellation token as a parameter here. And in fact, that's what we're getting yelled at for here. And fortunately, IntelliSense says, hey, don't worry. The smart folks at Microsoft and task.delay also allow you to pass in your token. But let's pretend they didn't, right? Let's pretend we're using somebody else's library, we have no control over this, and they don't allow us to pass in a cancellation token. What do we do? Well, there's a cool extension method called wait async, where we can pass in the cancellation token here. And essentially what this does, it bolts on that cancellation token to this task. So even if there's a task where we can't pass in a token, we can still make sure to cancel it by using wait async. But there is a catch here. And this is a really subtle thing, and that is if the task is already completed. So I'm not going to keep this code. I just want to explicitly show this as a completed task. So if you're running a task and it has already completed, or sometimes async task methods return task not completed. Sometimes that's valid. If the task is already completed, wait async will never run. So this actually won't cancel the task because, well, it's already completed. So sometimes if you know that the task might already be complete, you can bolt on wait async, but it might also be a good idea to just check to see if that token's canceled anyways afterwards, just so you don't keep running code. Although, down here, I'm passing the token, so the next line of code will cancel it anyways. But for this app, in this example, let's put it all back because we don't need to worry about any of that, because we can just pass in our token, happy days. Okay, so the next to do, we're awaiting top stories. So we're getting the top stories from the Hacker News API, we're clearing the collection, and then we're adding in the stories into a sorted collection here. This looks pretty good, right? We're awaiting the task. Like, how could this be any better? Well, let's again think about what's going on here. So let's say thread 1 calls refresh. Thread 1 comes all the way into here, eventually hits this await keyword, returns. Let's say get top stories is running on a background thread, and then when it's done, it goes back to the calling thread, and thread 1 jumps back in here to pick up where it left off. But then thread 1's going to enter this for each loop. And what if there's 1,000 stories in this top story list? What if there's 1,000,000 stories in this top story list? Well, now thread 1 has to iterate over all of them. And in the meantime, what that means is thread 1's busy. Our app is frozen. So again, our user's just going to be sitting, staring at an app, trying to tap buttons, trying to swipe. Nothing's going to happen. And again, we get a 1-star review, and they force quit the app, never to come back again. So what we can do to improve this code right here is tack on configure await false. So configure await false is an extension method on task where we can tell .NET, hey, I don't care about returning to the calling thread. Now, there will still be a thread switch when it's done, but now if thread 1 kicks off this task, kicks off this method, I should say, comes in here and hits the await keyword, thread 1 will return, get top stories runs in the background thread, and then when it's done, get top stories, or rather .NET will say, okay, great, thanks get top stories. What thread called you? What was the calling thread that I should return to? Well, configure await false says, don't even worry about it. Just go to the thread pool and grab whatever thread's available, and then continue running the code down here. So now, instead of returning back to thread 1 and maybe forcing thread 1 to do 1,000 iterations in this for each loop, a background thread will pick up where we left off. And this is also nice because what if thread 1's busy, right? Like maybe the user's scrolling vigorously and we need to return back to the calling thread. Well, if thread 1's busy, well, we also have to wait for it to free up. So with configure await false, we get the benefit of not overworking the calling thread, or rather not overworking the main thread, but also we don't have to wait for that calling thread to be finished, to be free, because it's just going to pick up with any available thread from the thread pool. So highly recommend configure await false. Specifically in my world, in the .NET MAUI world, in the mobile world, we do everything in MVVM architecture, so model, view, view model. If that means nothing to you, that's fine. As long as you remember the view is where all your UI code lives. And here where we are in the view model, this is all business logic. So none of this code touches the UI. So my rule of thumb is in the view model layer, I configure await false everything. In my services layer, I configure await false everything. And it does suck a little bit because you're going to start using configure await false probably 90–95% of the time in your app, and there's no way to change the default because configure await true is just the default. So if you do nothing, that's configure await true. So if you don't need to return to the calling thread, and in fact, if you want to avoid overworking the UI thread, configure await false is your best friend. Now, something really cool that was recently added in .NET 8 are these configure await options. So we have 4 enums here now that we can also play with. So this first one, configure await options.none. I should have just copy pasted that. There we go. So configure await options.none. This is the same thing as configure await false. It's a little unintuitive. The naming it none, probably not the best naming choice, but I've been on the other side of the naming battle. It's hard, I get it. But if you look at it, you'll also see continue on captured context. And that one is the same as configure await true. And you might start to be thinking, well, okay, I mean, that's cool, but why are we just renaming things for no reason? Well, the cool thing is here, there's two more that we haven't talked about yet, but also these are enums, so we can chain these together. So I can also say configure await options, continue on captured context, and force yielding. So remember when we looked at the compiled code earlier, we said .NET first looks to see, is that task already completed? Because if it is, no thread switch, great. Optimization, we're gonna keep rolling. But maybe we still want to force a thread switch. And this might seem a little bit weird, but I promise I've used this before, or if you've ever used a await task.yield, basically the same idea, because sometimes you need to update the UI. You want to yield the UI thread so that it can update something based on the result of a task, whether it had already completed or not. So we also get configure await options.force yielding, which is essentially task.yield, but inline, which is kind of cool. And then the other one, which scares the pants off me, is configure await options.suppress throwing, which, what did we just talk about? We always want to await every task, so we'll rethrow the exception so that we can handle it. We want to do that as good C# developers. Well, now you can tell it, no, I don't care. Don't rethrow any exception. But first, before I go on a rant about this, I am getting yelled at here, and I want to show you why. And it's because suppress throwing only works in some scenarios. There we go. So suppress throwing is not supported, or rather is only supported with non-generic tasks. So top stories returns a task of type, list of story models. So we can't actually use it here, but for something like task.delay, it would actually be valid because this is just returning a task. So with suppress throwing, actually, speaking of task.delay, this is one of the places where I've used it in production code, where I've said suppress throwing because, if this token is canceled, do I really want it to throw an exception here? Maybe, maybe not. But the only other place where I've seen this as, we'll say, a quasi-valid use case is, let's say you have a bunch of tasks you're kicking off all at the same time, and then you're just gonna say await task.whenAll. So you're gonna say, I've got 5 tasks, I wanna await them all at the same time, so await task.whenAll. But if one of those tasks throws an exception, that kicks out of your task.whenAll and doesn't allow the other tasks to complete. So if you want all the tasks to complete, you could use suppress throwing, but then remember to be a good C# developer, check each one of those tasks to see if it did fault, just in case, so you can handle that exception. Okay, so all that said, I'm just gonna erase all this and go back to configure await false. That's all I really wanna do. I just want a little bit of that performance improvement here. And that is good. Oh, and I forgot to mention, we'll return back to this minimum refresh time task, but if any of you are wondering why I'm doing this, I'm doing it, it's kind of a little hack we do as mobile developers where sometimes when you do a pull to refresh, these values might get cached on an edge server and they might come back within a couple hundred milliseconds. And 300 milliseconds is how fast it takes to blink your eye. So literally, the user might not see that little spinning indicator or any of the animations happen. And if that happens, then they're just gonna keep pull refresh and force our app to go out and make API calls a bunch of times. So what I do is actually, I purposely slow down your app a little bit, in this case by 2 seconds, just to make sure you see that spinning indicator for a couple seconds so you don't start hammering my backend APIs. Okay, moving on to the next to do. All right, so finally down here, right. So speaking of that minimum refresh time task, so one thing we're getting yelled at, which is kind of cool, is we want to put the token in. Great, but we're using .wait here. .wait's terrible. Don't ever use it. I kind of wish it didn't exist, although it kind of has to. .wait is what we call it's a blocking call. So the obvious solution here is we just need to await that task. So this is, there we go. So fun fact, yes, you can use async await in the try, catch, and finally block. But the reason .wait is bad is instead of the await keyword, which releases the calling thread if the task hasn't yet completed, .wait says, calling thread, you stay right here. You're not going anywhere, but I'm still running this code on a background thread. And so if you think about it, like if that's thread 1 that we're holding hostage with .wait, well, again, we're just freezing our app again. But maybe you're thinking, okay, whatever, like I don't write mobile apps, I just do backend APIs. I never have to worry about a UI, who cares about thread 1? I don't. Well, .wait's still bad because now you're using 2 threads every time you should only be using 1. And so your backend API is going to reach what we call thread pool exhaustion even faster because you're essentially doubling the amount of threads that you should be using. So .wait's bad for everybody. Don't use it. Avoid it if you can. And just instead, await the task. OK, so the next refactor, get top stories here. This one looks a little weird, and it kind of is a little weird, and it's kind of how the Hacker News API works, is that I have to first get the top story IDs, and then once I have those top story IDs, I can make iterative API calls to get the information about the stories. I wish they would just let me get the stories in one API call. I don't understand why I have to make so many API calls to Hacker News just for this very simple app, but that's the design they gave me. So what we're doing here is we're getting the top story IDs, and then one by one, we're going out and getting each story. And this isn't great because we're doing everything one by one. You know, what we should be doing is getting all of the IDs, or getting all the top stories at the same time. So what I'm going to do is I'm going to jump over here, and I'm going to copy paste some code from our good async await practices view model. And this code uses iasync enumerable. And this is really cool. Maybe you've never created an iasync enumerable method before, but I'll bet you've used it because with iasync enumerable, it unlocks the await for each loop. So now we can say await for each var top story in get top stories. There we go. And then this code here, where we add in that story to the list, we'll bump it up there, and we should clear the list before we iterate, and then delete all this code we don't need anymore. So,
sending the whole loop into a thread, into a single thread.
Sorry?
You're sending the whole loop into a single thread.
Let's hang on questions. I'm sorry, I truly don't know what you're asking. So what we're doing here is now in get top stories, we still have to get all the top story IDs, but then what I do is I create a list of tasks, and then I kick off a get story API call for every top story ID that I have. So essentially I'm firing off all these tasks at the same time, and then down here, we're calling task.when each. So this is a cool new API introduced in .NET 9, task.when each. So it just takes in our list of tasks, and anytime or as soon as one of these tasks has completed, then we can enter this await for each loop where, let's rewrite this code just a little bit. We'll say top story equals, there we go. That's a little easier to look at. So basically, as soon as any of those are done, it'll yield return the result. Now this yield return, maybe you've never used it before, or maybe you've used it in IEnumerable. Yield return doesn't mean we're exiting this method. It doesn't mean we're returning out of this method completely. It just essentially means we're temporarily yielding to whoever's calling this method to give this value. So really what's going on here is as soon as one of these stories is finished downloading from the API, we yield return, which means .NET comes into here and then enters this await for each loop where it adds that top story to our list. So as the results come in, I'm able to show that on the screen, whereas before, the user's just sitting there for like 20 seconds looking at a spinning indicator, seeing nothing change, whereas now we can feed them and stream them the data as it comes in. So even if it takes the same amount of time to get the data, it feels like it takes less time, and users can see those articles coming in, and they can tap on them as they complete. So So really, really cool stuff with async enumerable. But there's a couple things in here I want to call out. The first thing being this enumerator cancellation attribute. So if we didn't have it, we do get yelled at, which is good. But what it does is it takes this cancellation token and it actually passes it in down into the low-level framework iterator. So what does that mean? Well, more specifically, what that means is every time this for each loop iterates, .NET will automatically check this token for me. So I never have to see if this token's been canceled, because every time this loop iterates, thanks to that enumerator cancellation attribute, .NET's going to check it for me. If we didn't have it here, then we would want to do something like this down in our code, checking that token all the time, but we don't have to because we're using enumerator cancellation. The other cool thing, or the other thing I want to highlight here for you is inside of this task when each. So again, this is a new API that just came to us in .NET 9, and you might think, just based on every other method we've looked at today, is that we would pass in the token here, but as you can see, you can't. And that's because the way you bolt on cancellation tokens to task.whenEach is with this extension method. And yes, you can also say configure await false. So things start getting a little long here, but it's really, really cool. It makes for a really nice user experience so they can see the data coming in real time, and they don't have to just stare at a blank app. Okay, so now let's refactor this getStory method. So this is the method that calls the Hacker News API, pulls down that story that we're looking for, and we're using async await. We could probably do a configure await false here, but this looks pretty good. What could we do to improve this? Well, again, let's think about what's happening here. So the calling thread enters this method. So let's say thread 5 enters getStory. Thread 5 hits the await keyword, so it returns. This is going to run on a background thread, and then when it's done, we're going to switch back to, we're going to do another thread switch. And we've just had multiple thread switches inside of this method, which isn't terrible, but if we look a little closer, we can see that getStory returns a type task of type story model. Whoops. There we go. A task of type story model. And this method called getStory is also returning a task of type story model. So what we can do, because we're only using the await keyword here in the return statement, we can actually get rid of await and we can get rid of async and just return the task. So that saves us a thread switch, makes our code performance improve just a little bit more, and it essentially defers that thread switching to now whoever's calling this method, getStory. Okay, so one more refactor down here. We have the get top story IDs. We'll talk afterwards, man. We're running out of time already. So get top story IDs, it kind of looks the same, right? The only place where we're using the await keyword is in the return statement. So it looks like get top story IDs has the same method signature. And so, yeah, why not just get rid of async, get rid of await? We got to do task.fromResult here, but that's not too bad. And huzzah, performance improvement, right? Well, this is actually a trick question, because this is actually inside of a try-catch block. And so if we were to return the task, we would exit this method. We would leave this method. We would leave the try-catch block, meaning if this did throw an exception, we would never catch it here. So this is actually a bit of a trick question. We do want to keep return await in these scenarios where we are wrapping our code inside of a try-catch block, or if we're disposing of anything. But what we can do here is, instead of using task, we could use value task. Now, value task is very similar to task, but task is a reference type, and value task is a value type. So value task lives on the stack, whereas reference types live on the heap. And if we look closely at this method here, the first thing it does, it looks to see is the data recent. So if we've already pulled the top story IDs within the past hour, we don't need to make another API call, right? We can just grab the ones we already got. It's fine. But the first time this method runs, it's not going to have any data. So the first time it runs, we're going to call that await keyword and go get the top stories. But the second time it runs, we're not going to use the await keyword. And the third time it runs, we're not going to use the await keyword. And the fourth time it runs. So another way of saying that is, this is the hop path of our method, and our hop path does not use the await keyword. So if you have any code where the hot path does not use the await keyword, you can get a little bit of a performance boost by using value task, because you don't have to do all the initialization of building up a task and putting it on the heap, because that's more expensive, whereas pushing onto the top of a stack, just O of 1. So we get a little performance improvement here. Now, they're not exactly the same. There's a couple limitations of value task, like you can't pass around a value task, you can't reuse a value task, whereas you can do both of those things with task. But if you just remember that having a hot path of a method that doesn't use the await keyword and just returns a value task instead, you can just await it, happy days, get a nice little performance improvement here. All right. Whew. So I know I threw a lot of stuff at you. Let's sum it up. Let's talk about these async await best practices. So never use .wait, never use .result. They're both bad, they're both blocking. Like we talked about earlier, if you use .wait or .result, it blocks the calling thread from returning, while meanwhile running all that code still on a background thread. So you're using two threads when you only need one, and you risk locking up the UI thread. So we should always just use async await, but to be fair, there are still some scenarios, even in 2025, where we can't use async await. Like, for me, usually I see those when I have to implement an interface that has a method that just returns a bool. I can't, not a task of bool, I can't await it. So my recommendation there is you can actually replace both .wait and .result with these two methods string together, getAwait or getResult. They actually do the exact same thing. GetAwait or getResult is still just as bad. It's blocking. We shouldn't use it if we can just await it. But the reason GetAwait or getResult's a little bit better is if an exception gets thrown in that task, GetAwait or getResults throws our exception. So whereas if I use the .wait or .result keyword and exception's thrown, it throws a system.aggregate exception, which is an exception that holds exceptions inside of it. And so if you've ever had to debug those, you have to know you have to go one level deeper into your call stack. They're a little tough, especially for junior developers to figure out. So don't use .wait, don't use .result, but if you have to, GetAwait or getResult will at least give you a better exception, although you're still blocking, you're still using too many threads when you shouldn't be. Fire and forget tasks. Again, I know I'm biased, but you can use safe fire and forget. It's available on NuGet as async await best practices. It's also an open source MIT licensed library. If you just want to copy that little extension method, you're more than welcome to. But again, avoid async void. It is dangerous. I think we all know why now. But what's nice with safe fire and forget is you have this explicit in-your-face call that says, I know this is going to run in the background, and I know my code's going to continue. So you can avoid implementing async void. We can avoid return await. So if the only place in your method where you're using the await keyword is in the return statement, you can just instead return the task. But remember, if you're inside of a try-catch block, you definitely still want to await that task so you can catch the exception. Or if you're inside of a using, like a disposable block, you definitely still want to return await because you don't want to dispose of an object that you're using inside of that method. So we can avoid return await, except in those special cases. Utilize configure await false. So if you don't need to return to the calling thread, which for me, this is anytime I don't need to return to the UI thread, I configure await false everywhere. Now, there's a giant caveat here, and that has to do with something called the synchronization context. Now, like I said, I just published a 4-hour course where I literally spent a whole hour talking about synchronization context, and we don't got time for that right now. But long story short, synchronization context is what .NET uses to return to the UI thread, return to the calling thread. And in ASP.NET Core, it doesn't have a synchronization context. So technically, in ASP.NET Core, configure await false is the same as configure await true. But on any other platform where we have a synchronization context, configure await false is always best to use if you don't need to return to the calling thread. And then also we have configure await options. So these are kind of the new hotness that came out in .NET 8. So if you want to be a little bit more explicit, instead of saying configure await true, you could say configure await options dot continued on captured context. Or if you want to do crazy stuff like suppress throwing, which you better have a real good reason. I'm gonna ask some questions when I see that in a PR. You can chain these together because they're all enum. So you can force yield, you can suppress throwing, and you can not return to the calling thread all at the same time. Utilize value task. So like I mentioned, it's basically an optimized version of task. It lives in the stack instead of on the heap, but it does have some restrictions around it. So don't go crazy. Don't create new value tasks in your code. Don't go passing around value tasks. Don't reuse value tasks. That's not what they're there for. But you're totally safe if you just use it for your method's return value and just think of it as async await. But again, this is when your hot path doesn't need the await keyword. Async enumerable. So if you want to stream data, if you want to give users updates in real time, so they're not just looking at some spinning indicator, async enumerable is really, really cool. It allows us to show that data as it arrives. It's a better user experience, but keep in mind, you want to use that enumerator cancellation attribute on your cancellation token, because again, we're good C# developers. Every time we create an asynchronous method, we're going to have a cancellation token parameter. But in this case, slap on that attribute, and then we get a little performance bump from .NET checking if our token's expired or not. Wait async. So again, if we're using somebody else's code and they're not good developers and they don't allow us to pass in a cancellation token, we can always bolt one on by using .wait async. Just keep in mind if the task is already completed, that wait async cancellation token will never throw that operation canceled exception. So slight nuance there, but for more or less, you can just bolt that on to cancel your tasks. Okay, async disposable. So this is one I didn't have an example in the code to show you, but wanted to go over it here because the syntax is a little wonky, right? Like if we look at this, we have the await keyword here, but the await is happening in the disposing. But speaking of disposing, I should explain what async disposable is. If you know what idisposable is, this is just an asynchronous version of it. So idisposable is where we can put a little extra code that needs to maybe free up some resources when we're done using a class. Async disposable allows us to do the same thing, but with async await. So for I/O heavy things like file stream, this is great because maybe you just read in a 30 megabyte file and you got to dispose of it. Well, if you just did that with idisposable, then you might block your UI thread. But with async disposable, it'll do that using async await, which is great. But look at the syntax. It makes sense, but at the same time, it kind of doesn't. But that's just because the await keyword goes here, but the await doesn't actually execute until the disposing starts. So when we exit the using block, that's when the async await action is going to happen. So yes, we can await, we can add configure await false, but all of that is going to execute a little later with the async disposable. But still really great stuff. Highly recommend it if you can take advantage of it. Okay, so if you want to go even deeper, you can find a link to the course that I've recently published on DomeTrain. So it's available at dometrain.com. Like I said, this is a 4-hour course that I just published a couple months ago. Really, really proud of this because this is all the stuff that I wish I would have known when I started working with C#. It would have saved me, gosh, months of my life debugging things. So this is where we go over some of the topics we talked about today, but we go even deeper. So like what is synchronization context? What is execution context? What is, like how does async await even work? Like how does the Roslyn compiler even know where to use it? And all these things called duck typing, it's all there for you. It is a paid course. I don't control the platform. I just made the content, but it is something I'm really proud of and highly recommend it. And if you want to spend 4 more hours with me, please do check it out. Okay, so now's the time. If you haven't had a chance to take a picture of this slide, you can take out your phones, grab this QR code, it takes you to this URL. And again, this is where you can find everything we covered today. So this is where you can see the slides, this is where you can find a recording of this talk, this is where you can find all of the source code, you can find the links to the async await best practices NuGet packages I've made, links to the DomeTrain course, and then I've also put a bunch of articles in here that were helpful for me when I was first learning how to use async await in C#, and I know they'll be helpful for you too. Thank you. All right, we got 5 minutes. Yes, sir.
So you had a whole bunch of bad practices there. Do the analyzer defaults warn you for all of these, or do we have to turn things?
Oh man, so analyzers, yeah. There's a couple good ones that, if you're using JetBrains is really, really good about warning you about stuff. But I do want to go on a quick rant if you allow me, and that's the warning we get. Remember back here, we weren't awaiting this call. And by the way, there's better ways to kick off async task methods than doing it in your constructor. You shouldn't do this in general. This is more for the demo. But if you look at the warning, it just says, this call is not awaited. The execution of this method continues before the call is completed. And when I was a new developer, I said, yeah, no shit. That's why I didn't await it. Like, why is this even a warning? And I worked at Microsoft for 7 years, and I tried to get the runtime team to add in more just to say, and if an exception is thrown inside this task, you'll never see it. Like, because to me, that's the big reason. Like, that's why we should be awaiting it. So yeah, things like these, there's good analyzers like these that I turn on warnings as errors for. And that also saves you the headache of like looking through PR reviews with a fine-tooth comb. Like, did you miss a task? Is there one hiding in there we didn't await? So yeah, there's analyzers we can turn on for all of these. And other good ones are like this one here where it says, hey, this has an overloaded method where you're not passing in your cancellation token. So yeah, I turn on all of these in my apps, and it's really, really helpful. It kind of forces you into best practices, and if you turn them off, or if you do like a suppress, or if you suppress those warnings, like you better have a good reason. But yeah, definitely, there's some really good analyzers out there that you can make sure that any new pull request that comes in will still be good. Good question. Yes.
A bit more of a comment than a question. Just one of your ones, you did an optimization of moving from an async method awaiting when it was just one line.
Yep.
And made it a straight public task.
Yeah, just returning the task.
If the called method throws an exception, you're not in the stack trace if you aren't async await.
Yeah, so you're right. This does modify the stack trace, and that's always the argument I hear against doing this. And he's not the best person to pick a battle with, but David Fowler also advocates against doing this. But I can tell you, this has never been a problem. I've had bugs be thrown, and you can still find them and solve them. Yeah, like your stack trace might look a little different, but it's never been a problem in my experience. So yes, it does change the stack trace a little bit, but
it has been a problem in my experience.
Oh, interesting.
Not knowing which method called the throwing method. So, like, the method that was actually thrown was called from multiple paths that were called from the same place. So we didn't actually know which one was thrown.
Gotcha, fair enough. Okay, yeah, so maybe still await it. No problem. Yes, sir.
You mentioned configure await false isn't needed for ASP.NET Core. I run all in ASP.NET Core at the moment.
Yeah.
I haven't been using cancellation token really at all. Is that needed in ASP.NET Core?
Yeah, because again, you don't know how long that task is going to run. So when you call a method that returns a task, that could run for 20 minutes. Who knows? So yeah, you still want to give that control and allow somebody else to cancel that method. And I mean, we do have 2 minutes. So yeah, synchronization context. What's kind of interesting is really what's happening under the hood. When we say configure await false, what we're actually doing is setting the synchronization context to null. So in ASP.NET Core, there is no synchronization context, so it's always null. So that's kind of why configure await false and true do the same thing. But yeah, definitely cancellation tokens, super important. If you control all the code, you can go in and fix it. But if you're ever going to publish APIs or libraries, like you gotta have those in there for us. Otherwise, yeah, I think I saw. Oh, yep.
What's your opinion on like calling the method async method in one line and wait for it in a data or
Oh, totally cool. I mean, that's what we're doing down here in that try catch finally block, as long as you await it. And so that's a tough part. Sometimes I've had to await it later. If you can avoid it, but I've had to like save it as a field and circle back to await it later. But yeah, you don't always have to await it in line. Just don't lose track of it. That's the only reason why it can be dangerous. Good question. Yes?
When I started with this, I thought, okay, I have a cancellation token, then I just can cancel things. But you're not sure that you can. You're not stopping.
Yeah, I mean, because
If you're calling the database, it will still run, for example.
yeah, I mean, there's always a level of trust somewhere, and really, what we're assuming is that when I call,
You have to do this sometimes.
right, yeah, or passing it in, like that, and taking advantage of the existing .NET APIs. But yeah, so when you do add in this cancellation token, that's actually a really good point. So not only do we have to have a cancellation token as a parameter, but before we continue on with any logic, we should check to see if it's canceled. And if there's not something that we can pass the token into and check it for us, then yeah, token.throw if cancellation requested is what I always use and what I recommend. But make sure you do that in your code, and then the rest of us, we just kind of have to trust that everybody else did it in their code. That's a really good point. Thank you. Did I see one more in the back? All right. Well, thanks so much, guys. We'll see you around.